example, if you take internet, there are multiple paths exist between the source and the destination, and switching helps in deciding the best route for data transmission. Since big networks like internet, there are multiple paths, and it should also provide a feel like one-to-one connection. We have seen what is switching. Now we will see what are the various techniques in switching. Basically, switching techniques are classified into three types: circuit switching, message switching, and packet switching. And packet switching is categorized into datagram approach or virtual circuit approach. We will see one by one in detail. Firstly, we will start with circuit switching. In circuit switching, there is always a dedicated path that is established between the sender and the receiver. It means between the sender and the receiver, there will be a dedicated path. Before data transfer, connection will be established first. It means before data is transferred, we have to establish the connection. Once the connection is made, then only data transfer begins. For example, telephone network. Telephone network is a well-known example for circuit switching. Sender first dials the number. Once the connection is established, then they can talk to each other. So dialing the number and establishing the circuit is started in the first phase, and then the data transfer happens. Basically, circuit switching has three phases. Number 1, connection establishment. Number 2, data transfer. And number 3, connection disconnection. So if you observe here, before data transfer, connection is established. That is what is mentioned here. Before data transfer, connection will be established. We will see an example and it will be very helpful for you to understand this in a better way. In this example, let's say there is a big network. Phase number 1 is dealing with connection establishment. Suppose if he is the sender and he is the receiver, so phase number 1 is establishing the connection. This green line represents that this is the connection that is established between the sender and the receiver. Suppose if sender has a message to transmit. Before the message gets transferred, we see here that the connection is already established. And after the connection is established, the data transfer happens. So this is what a circuit switching is. So before data transfer can happen, the circuit or the connection is established. And all the communication uses this channel or this connection, and this connection is reserved between the sender and the receiver. After phase number 2, now comes phase number 3. Phase number 3 means connection disconnection. Now if you observe, the green lines are removed. It means the connection gets terminated. This is what circuit switching is. So far we have seen what is circuit switching, and this is the first technique in switching techniques. Now we will see the second technique, the message switching. In message switching, it uses store and forward mechanism. It means the message is transferred as a complete unit, a single unit, and forwarded using store and forward mechanism at the intermediary node. If you don't understand this, just wait for my example. Suppose if sender wants to send a big data, and this big data cannot be transferred in a single stretch. So it is broken into individual entities or pieces, and each of these pieces are transmitted to the intermediary node. This intermediary node receives all the small pieces and constructs the full message. After getting that full message or the complete unit, then only it forwards the data. This is what message switching is. We will see an example now. It will be clear for you. Suppose if this is the sender and this is the receiver, if the sender wants to send a message, this big message is broken into individual pieces. And finally, all the individual pieces are collected and stored here. After getting the complete message, then comes the forward phase. So first it stores all the pieces and then it forwards. So the complete message is stored and then it is forwarded. This is an example for message switching. And if you observe, the message has reached the receiver now. Coming to this point, message switching is not suited for streaming media and real-time applications. For example, if sender is sending a real-time communication, two people are talking over voice over IP phone. So we can't expect the intermediary node to collect all the data that is sent by the person and forward it, because it is a real-time communication. For real-time applications, message switching technique cannot be used. So for streaming media like real-time communications or live data transfer, or for real-time applications, message switching technique will not be suitable. And so far we have seen circuit switching and message switching. Now we will move on to the third switching technique, that is the packet switching. Packet switching. The internet is a packet switched network. Here, the message is broken into individual chunks and each of these chunks are called as packets. This is like our message switching, where message is broken into individual chunks called packets. And here is the difference between this packet switching and the message switching. In packet switching, each packet is sent individually. Suppose if a big message is broken into 5 pieces and each of these 5 pieces can be sent individually. So if each of these 5 pieces can be sent individually, each of the pieces should have some information that uniquely identifies the source and the destination. Each packet will have source and destination IP address. In addition to source and destination IP address, we will also have sequence number, because we know very well that each packet is sent individually. So any packet may be received at the destination in any order. So we need to reorder the packets, and sequence number will help the receiver to reorder the packets. Also, if any packet is missing, this sequence number will help to detect the missing packets. At the same time, this sequence number will help the receiver to send acknowledgement. Say for example, if packet number 5 is received, it will send packet number 5 is received as an acknowledgement to the sender. In case, if packet number 6 is not received by the destination, it will not send any acknowledgement to the sender. So the sender will wait for this acknowledgement for a certain period of time. If no acknowledgement is received for packet number 6, it understands that the packet may be lost, so it retransmits that packet. Sequence numbers will help the receiver to reorder the packets, to detect missing packets, and send acknowledgements. Basically, packet switching has two approaches. We will see what are these two approaches in packet switching. There are two approaches to packet switching: Datagram approach and virtual circuit approach. We will see Datagram approach now. Datagram packet switching, it is also known as connectionless switching. It means each independent entity is called as datagram. If the message is broken into 5 pieces, then each of these 5 pieces are called as datagrams. And each datagrams contain destination information, and the intermediary devices uses this information. Which information? This destination information to forward the datagrams to the right destination. Suppose if the original message is broken into 5 datagrams, each datagram will have destination information, and these destination information will help the intermediary device to forward the datagrams to the right destination. So in this case, each datagram will take different routes. It means the path is not fixed here. Unlike circuit switching, the path is not fixed in datagram approach. Who takes this routing decision or forwarding decision? It is the responsibility of the intermediary nodes to take the routing decision or forwarding decision to forward the packets to the right destination. We will see an example. It will be very easy for you to understand now. So this is an example where this is the sender and this is the receiver. Now let us assume that the original message is broken into 4 datagrams. Datagram 1, 2, 3 and 4. Now if you observe, datagram 1 is going this way and datagram 2 takes this path. Now datagram 1 is going this way, whereas datagram 2 is taking a different route. And if you observe, datagram 1 is using a different way which is not used by datagram 2, and this is not used by datagram 3. And if you observe, datagram 4 is moved faster than datagram 3. 1, 2, 4 and 3 is the order of the datagrams that are received. But receiver knows how to reorder this because each datagram has sequence numbers. So these sequence numbers will help the reordering process easily. Now the reordering is done by the receiver and it constructs the original message as like it was sent by the sender. So this is an example for packet switching and the datagram approach. We have one more approach in packet switching, that is virtual circuit approach. Virtual circuit switching is also known as connection-oriented switching. So in the previous case, that is the datagram approach, it is connectionless, where every individual datagram takes a different route. But here, in the case of a virtual circuit switching, a pre-planned route is established before the messages are sent. It means before sending the messages, some route is decided using some virtual circuit identifier. So there will be a virtual circuit identifier followed in the scheme, and this route is decided before the data are sent. Call request and call accept are special packets that are used in the scheme to establish the connection between the sender and the receiver. So in this approach, the path is fixed for the duration of a logical connection. In the previous technique, that is the datagram approach, the path is not fixed, but still it is a packet switching technique only. But here, this virtual circuit approach, the path is fixed for the duration of a logical connection. We will see an example, then it will be clear for you. In case, if this is the sender and this is the receiver, you can see that there is a logical path that is established and data transfer is happening only through this way. So packet number 1, 2, 3, 4, 5 and 6, all these packets are traveling in this route only. And after the data transfer process is over, this connection gets terminated. If the same two computers or same two nodes wants to exchange data, we can't guarantee that the same route will be taken for the next data transfer also. And the route will be decided based on the availability. We will have a simple recapture now. So basically, switching means finding the best route for transferring the data from the sender to the receiver, and particularly in a large network. So switching basically has three techniques: circuit switching, message switching and packet switching. And packet switching has two approaches: datagram approach, virtual circuit approach. And that's it guys. We are at the verge of completion.